Hello everybody, today video number 6 of this course. Today we'll speak about wind and airflow strategy. Just like passive heating, passive cooling is an important strategy for achieving an energy efficient building. Harnessing wind and controlling airflow is a key element for utilities passive cooling through natural ventilation. Today in this course we will study the basic of air movement and how air move around your building as well as within your building. You will learn when wind can be helpful for your passive cooling and when it's not important. Furthermore, you will learn about strategies you can use to enable and increase natural ventilation in your building. Today we will using Flood Design through Revit and we will show you how to visualization airflow around your building and how this visualization can translate to useful design discussions. Topics of today will help you to understand how airflow around and in your building. Determine what type of natural ventilation are most applicable for your building and the strategies to implement them. And use flow design to view the airflow around your building design in Revit. And first, we need to know some information about wind and airflow. Wind move under pressure control. When there is a difference in pressure, the wind move from place to another place and then contributes to natural ventilation. In usual, wind move from high pressure to low pressure. If you look to this shape, you will understand the wind move from high pressure to low pressure and sometimes create air vortex when building is short. But when building is very high, that's help it, wind to go far. When height of building is be short, that help to create air vortex and then help to increase air flow. When distance between buildings is small, that help to create air vortex and then create increase air flow. There is a lot of wind and airflow strategies. In our climate zone, arid climate, we use the difference in building height or difference in massing of building, shading, opening window or opening pass or wind catcher malaf. We will speak about some of these strategies in our practical part. Now we will begin practical part. So I prefer everyone opening full design program to try with us. Now practical part. First open your project in Revit and then export it to full design, CAD formats, DXF, next. Okay. Now full design, open, import. You don't need to choose your location. It will be from Revit. If you look here, you will find a lot of settings. There is no difference between the settings. All of them have same results. The difference only in visualization, 3D mode or 2D mode, velocity or pressure, track plot, rows out track plot, surface pressure or no, plane or flow line, shape of flow line, smoke, tube. You can choose anything. If you look to this building, you'll find this phase have high pressure and this phase have low pressure. That's help to increase airflow speed. Also, the building shape or mass of this building have different in height. This help to increase airflow speed. Also, it have open patio with three sides. This create difference in pressure, which help to increase speed of airflow. You will find here this open patio wind catch. You also note that here, after building, there is air vortex. You must take in your account in your building or on your design, create difference in pressure in your building. That's help to increase airflow speed and increase ventilation in your building. You will notice that this building have a lot of strategies that help to increase natural ventilation inside this building and make this building a high performance building. You must take in your account in your project, create difference in pressure or create strategies that help you to create or increase natural ventilation inside your building or project. I hope this video help you to understand the airflow strategies, and if there are any questions I will be happy to hear that. Thanks for your time.